The periodic table arranges elements so that similar chemical characteristics are grouped together. It is the electron arrangement of each element that determines its place in the periodic table. A Bohr-Rutherford diagram for the first element in the table, hydrogen, shows us a single electron, occupying the first allowable orbit around the nucleus of the atom. Only 2 electrons can occupy this first orbital shell. Those 2 electrons are present in the helium atom. These elements, hydrogen and helium, are the only 2 which can share this first orbital shell. The second orbital shell, however, can contain up to 8 electrons. 8 elements have a pair of electrons filling the first, inner orbital shell, and this as their outermost orbital shell. Lithium is the first element in this second row of the table, with a single electron in its outermost shell. 7 other elements, each with 1 more electron, complete this second row of the table. Neon has a full complement of electrons in its outermost orbital. Helium also has a complete complement of electrons in its outermost orbital. So it is aligned in the table above neon. At the other side of the table, hydrogen, with only 1 atom in its outermost orbital, is aligned with lithium, also with a single atom in its outermost orbital. The next row of the periodic table has a third orbital more distant from the nucleus that can also possess a maximum of 8 electrons. 8 elements have 2 orbitals filled with electrons and 1 or more electrons in their outermost orbit. These elements align neatly under the previous row. The fourth row of the table breaks up our tight little grouping. 18 electrons are added in this row, but only some of those in the outermost orbit, as the distribution of electrons between orbitals becomes more complex, giving us a row of 18 elements which must be aligned with the previous rows. The chemical similarities between elements is most striking when outermost orbitals are nearly empty or nearly full. So the table is aligned by columns in this manner. The next orbital can also contain 18 electrons. So the 18 elements which make up the row fit neatly below the previous one. The final 2 rows of the table present a new difficulty. The next 2 orbitals can contain up to 32 electrons. Although not all the elements in both rows have been discovered or created, this gives us a potential for a row of 32 elements. One way of dealing with this is to simply align the elements in the previous rows in the same manner as before, keeping the most chemically similar elements in the same columns. This arrangement makes the table difficult to print and view in a book, let alone on a small video monitor. Although this form of the table is conceptually the best one, the practical solution is to clip a section of the last 2 rows, a set of relatively uncommon metals known as rare earths, and slide these 2 sections below the rest of the table, allowing it to remain 18 elements wide. This is the form of the table most often seen.